In this video, we're going to learn the difference between empirical and molecular formulas, and we're going to learn how to calculate them. We know that formulas give a relative number of atoms or moles for each of the elements involved in the compound. We know that they are always whole number ratios. The main difference between empirical formulas and molecular formulas is the empirical formula is the formula with the smallest whole number ratio of atoms. So it is not the true or the actual formula. The molecular formula is the formula that we've been using in these past units. It's the real formula. So when we calculate empirical formulas, the first thing we want to do is change the element percentages to grams. So the problem is going to give you those percent compositions. And so we're going to change those to grams. Then we're going to convert those grams into moles using the conversion factors that we practiced a few assignments ago. Next, we'll divide the number of moles for each of the elements by the smallest number of moles that we calculated in step 2. And then step 4, we're going to make sure that we have whole numbers, and if we have to, we're going to multiply those numbers by a 2 or a 3 or a 4 if we do not have a whole number. And that'll make more sense. I have an example to show. And then the last thing we're going to do is write formulas. Some cautions: be careful. Don't round off your numbers prematurely. Second thing is, don't forget your significant figures. We're always making calculations using those sig figs. And then third, you really should be showing your work. Our example says a compound is analyzed and found to contain 25.9% nitrogen and 74.1% oxygen. We want to know what the empirical formula is. Step 1 says that we need to change the element's percentage to grams. So we're just going to cross out percent and put the symbol for grams there. Step 1 is done. Step 2 says we're going to convert grams to moles. So remember when we did that, we used the conversion factors. But our first step is to identify the mass. So we have 25.9 grams for nitrogen. And then we're going to have the conversion factor, 1 mole, over the atomic mass of nitrogen. So look on your periodic table, find nitrogen, and you will see the atomic mass is 14.01 grams. When we cancel like terms and then we divide across here, we end up with 1.85 moles. All right, we're going to do the same thing for oxygen. So oxygen, we have 74.1 grams. We're going to look on our periodic table and we see that oxygen is 16 grams. Cancel out the grams because they're located on top and bottom. Divide, and when we divide this, we end up with 4.63 moles. All right. Our next step, step 3, says we're going to divide the number of moles by the smallest number of moles. So we have 1.85 here. This is my smallest mole compared to the 4.63. So we're going to divide both of these by 1.85. That cancels out your mole. We're going to be left with a 1 for here. And then when we do the math, we get a 2.50. Now, we know that empirical formulas have to have a whole number. And that's what our next step is, change to whole numbers. So our 2.5 is not a whole number. Because that 0.5 is a half, which was 1 over 2. Remember that step, it said whatever it is, we're going to multiply it by that denominator. So we're going to multiply both of these by 2. That's going to give us a 2 there and a 5 here. So now I have all whole numbers. And the last step is to write the formula. So I have N2O5. And this is the empirical formula. And EF stands for empirical formula. Calculating molecular formulas are pretty straightforward again. We're going to determine the empirical formula. Sometimes we'll be given that in the problem, and sometimes we'll have to calculate that. We need to then calculate the molar mass of the empirical formula, then divide the molecular formula's molar mass, which is given in the problem, by the one that we just calculated for the compound. And then we're going to multiply the empirical formula subscripts by the number that we have calculated, and then write the formula down. Again, show your work. Don't forget about sig figs, etc., etc. All right, I have a compound, has an empirical formula of NO2. The colorless liquid used in rocket engines has a molar mass of 92.0 grams per mole. So here is my empirical formula. Here's my molar mass. We want to know what the molecular formula of that substance is. All right, so step 1 says to determine the empirical formula. I got it. Empirical formula was NO2. Next, we want to calculate the molar mass of the empirical formula. So we have 1 nitrogen in our formula. Nitrogen's atomic mass from the periodic table is 1401. And then we have, for the oxygens, 2 atoms of oxygen. Oxygen's atomic mass from the periodic table is 16.00. And we multiply that across, we get a 32. And these are both in grams per mole. Anyway, we add these down to get the molar mass. So we end up with a 46.01 grams per mole. Okay, so that is our molar mass for the empirical formula. All right, next step is to divide the molecular formula's molar mass by the one we just calculated. So here is our molar mass of the molecular formula. So we're going to take 92.0 grams per mole, and we're going to divide that by the one we just calculated. When I do this, my units cancel out, and I end up with 1.999, which for the whole number will be a 2. All right, see this 2, then, step 4 says we're going to multiply the subscripts in our empirical formula by this 2. So our empirical formula was this, and we're going to multiply that by 2. So we end up with N2O4 as our molecular formula. So here's our molecular formula. Analysis of a compound showed that it is 65 carbon, we have some hydrogen, and then we have oxygen. That's for the remainder. So right off the bat, I know I have 100%, and I need to subtract the 65.45, and I need to subtract off that 5.493. Now, why am I doing that? because the rest of it was oxygen. Since we're dealing with percents, we know that the total is 100, so we can take the 100 total and subtract the knowns for carbon and hydrogen, and what's left over is going to be the percent for oxygen. And so when I calculate that, I get 29.057%. Okay, now remember, this is asking us for, and here's our molar mass right there. And we want to know the empirical and the molecular formulas. Okay, so we're going to start with the empirical formula always. Remember, the first step was to change those percents to grams. The second step was to convert those grams to mole. So we have carbon, our grams of carbon. We're going to use the conversion of the mole over the atomic mass from the periodic table, which is the mass of that element. And when we do that, we get 5.450. Now, I've got 4 sig figs for my answer. Then I have hydrogen. The mass of hydrogen is going to be converted to moles. On the periodic table, it says my mass of hydrogen is, the atomic mass of hydrogen is 1.01. And we get 3 sig figs. And I'm looking at these numbers. There's 1, 2, 3, 4 here. 1, 2, 3. Remember, I have to use the least amount of significant figures for my calculations. Oxygen is the last one. We calculated what its mass was. I'm sorry, this is sloppy. It's my pen. I need to get a new one. It's having problems. It's challenging me. Alright. These are all moles for our units. Alright. The next step was to divide all of them by the least or the smallest number. So this is my smallest number. So I will divide them all by this number. When I do, I get a 1 there. When I divide this one, I get a 2.99. So my round, or when I round it to get the whole number, I get a 3. And then I get a 3.00, which is my 3. So to write the formula, I've got C3H3O. And this is my empirical formula. Alright guys, I needed some more room, so I went ahead and opened up a blank slate here for us to work with. We need to bring a couple of pieces over from that previous slide though. The empirical formula that we had just calculated, we're going to need that. And we're also going to need the molar mass of that molecular formula. And remember, this was given in that problem. So that's where I'm getting it from, is just from the reading. Alright, So we are ready to get started. Step 1 was to determine the empirical formula. We got it, C3H3O. The second step is to calculate the molar mass of that empirical formula. So remember, we're going to identify each of the elements, how many atoms there are of those elements. So there's 3 hydrogens and 1 oxygen. And then we're going to multiply that by their atomic mass. So we're going to get that information from the periodic table. So when we look at carbon, we see its atomic mass is 12.01. So we get 36.03 grams per mole. Hydrogen's atomic mass will give us 3.03 grams per mole. And then there's 1 oxygen, and its atomic mass is 16.00. Now, in order to get the molar mass of this, we have to add all of this together. When we add all this together, we get 55.06 grams per mole. Now, this is the molar mass of the empirical formula, which was step 2. All right, step 3, we want to divide our molecular formula's molar mass by the one we just calculated. So we're going to bring down that molar mass from the problem, and we're going to divide it by the one we just calculated. This cancels out our units. And when we do that math, we get 1.999, so we can round that to a good whole number 2. Remember, that whole number is what we're going to multiply the empirical formula with in this next step. So we're going to bring that empirical formula back down. And we're going to multiply all of that by the 2 that we just calculated. Okay, so that means our molecular formula then is going to be C6H6O2. And again, that's our molecular formula. Make sure you label that. Don't hesitate to reach out if you have any questions. This gives you 3 good solid examples. Good luck.